Hi, welcome to our video series on mastering object-oriented programming in Java. In this video, we're going to talk about encapsulation in Java in detail. First, let's talk about procedural programming. Don't know what it is? Don't worry, I got you covered. Procedural-oriented programming is a paradigm that uses a linear top-down approach to design and develop software applications. In procedural programming, a program is divided into smaller, more manageable procedures called functions, which are executed sequentially. These procedures or functions can share some data, referred as data members, but do not have a natural way of grouping related data and behavior into a single entity. In procedural programming, the emphasis is on designing procedures that perform specific tasks and can be reused throughout the program. The data and behavior are not necessarily encapsulated together into a single entity, and data can be modified or accessed from outside the functions or module that define it. In contrast, the object-oriented programming focuses on more creating objects that have both data and behavior. In object-oriented programming, we wrap the related functions and data into a single unit called class. The data is referred to as properties and the functions which operate on the data as methods. And this is what we call encapsulation. The encapsulated data and methods are hidden from other classes and can be accessed only through public methods or interfaces provided by the class. In Java, encapsulation is achieved by declaring the class variables as private and providing public methods to access and modify them. This ensures that the data is accessed only through these methods, which can perform additional checks or validation before returning or modifying the data. To illustrate the idea of encapsulation, let's consider an example of a class named vehicle that has several data fields such as the number of passengers a vehicle can carry, its fuel capacity, and the average fuel consumption. We'll also create a method called range which will calculate the range of the vehicle. We can encapsulate these data fields by making them private and provide public methods to access and modify the values of this field. So let's jump into it and create these fields. This code demonstrates the idea of encapsulation. Here we group the related methods and data fields inside a single entity called class, and the name of the class is vehicle. And we have provided a public method, that's the setValue method, to access or modify these private data fields. We have also provided a public method called getValues which will print this information on the screen. If we go to our main class, and inside this main class I have created one vehicle object, and using the setValue method, I'm setting the value of data fields, that is number of passengers 7, fuel capacity 12, average mile consumption 50. And by the help of getValues method, I'm printing this information. So if we run this program, and you can see the code runs successfully and we get our output, that is the number of passengers can carry 7, the fuel capacity 12, and the range of this vehicle is 180 miles. Now, as you can see, these data fields are private. So this achieves our data hiding concept. That means no other classes will be able to access or modify these fields directly. Here you can see I have created one more class, that's the food class, and inside this food class I have created one object of the food class. This food class extends the vehicle class. Now if we try to directly access the data fields using this object, we will not be able to do so. Let me show you. Here you can see it shows the number of passengers as private access in vehicle. So this demonstrates our data hiding concept. That means no other class except this vehicle class is able to access these data fields directly. However, this food class will be able to access these data fields or modify them using these public methods that I have provided. Here, instead of directly accessing, we can call this setValue function and set the data fields a value, that is, let's say 6, 8, 12. And using the same object, we can call this getValues method, and here you can see we'll get the result of this program, and it says the number of passengers can carry 6, the fuel capacity 8, and the range of this vehicle is 96 miles. Here you can see the only way to access the data fields outside of this class is by using the public methods, that is the set value, and if we want to print the information, we have to use this get value method. The other benefits of encapsulation is that it improves maintainability. The encapsulated method allows you to modify the implementation of the vehicle class without affecting the code that uses it. For example, here we have the range method, and this range method is implemented like this way. If we wanted to change the way this range method works, we could easily modify it without changing the other part of the code. Another benefit of encapsulation is reusability. Suppose we are developing a software, and inside that software we have a number of classes, and in those classes our vehicle class is one of them. So then this vehicle class can be used across different parts of the program, making this code more reusable. So this was all about the encapsulation in Java. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more videos on Java and other programming topics.